I was walking around the farm and feeling quite blue. Then I smelled something gross and acrid wafting to my nostrils.
Ew.
My lungs were all inflamed and NO2 is to blame. It's 'cause of lightning that it came. Then I threw up big ol' chunk. It stunk unlike CO2, polluting life for me and you. It all started with a big zap.
It's not trivial because of its molecules.
Because its odd number of valence electrons makes it a free radical.
Its double and single bond makes one string 1.5.
Its Vesper structure is bent.
And 204 NO2.
Decomposition reaction.
Its synthesis reaction is reversed.
Dimethyl hydrazine
plus
hydrazine
plus N204.
known as a chemical reaction. It all started with a big zap.
I was walking around the farm and feeling quite blue. Then I smelled something gross and acrid wafting to my nostrils.
Ew.
My lungs were all inflamed and NO2 is to blame. It's 'cause of lightning that it came. Then I threw up big ol' chunk. It stunk unlike CO2, polluting life for me and you. It all started with a big zap.
Yes, that is the sequence of atoms in nitrogen dioxide, ONO. But nitrogen dioxide is no joke. Not only is it an extremely toxic gas with an acrid smell, but its presence in the atmosphere puts it at the root of several environmental problems. At first sight, NO2 seems similar to CO2, carbon dioxide. But an NO2 molecule contains one more electron than CO2. The extra repulsions that brings causes NO2 to be a V-shaped molecule with a bond angle of 134 degrees, unlike linear CO2. This extra electron makes NO2 a free radical and rather reactive. If you cool NO2 gas down, it changes from being a brown gas to a colourless liquid. What has happened is that N2O4 has been formed. Two NO2 radicals have shared two unpaired electrons to form a weak nitrogen-nitrogen bond. If the liquid is warmed, it boils at 21 degrees to a brown gas, partly splitting up into NO2 again. As the gas is heated more, the colour gets darker, until at 140 degrees C, all the N2O4 has split into NO2. Dinitrogen tetroxide, as the liquefied NO2 dimer is called, was used as the oxidizer in the fuel for the United States Titan rockets. They were used to launch the Project Gemini manned space flights in the 1960s, and, more recently, for unmanned probes sent to Mars, Jupiter, Saturn, Uranus, and Neptune. It was also used in the orbital maneuvering and reaction control systems of the Space Shuttle orbiter. A combination of hydrazine and 1,1-dimethylhydrazine was used as the fuel, which ignited spontaneously when mixed with the N2O4 oxidant in a very exothermic reaction. The downside is the toxicity of the chemicals involved. NO2 is very toxic. If inhaled, it can inflame the lining of the lungs.
Also causes pulmonary edema and fatality in lungs. Effects depend on level and duration of exposure. Moderate exposure causes cough, hemoptysis, and dyspnea, and chest pain. High exposure can lead to pulmonary edema or bronchitis obliterati. Also causes eye, nose, and throat irritation. May cause an increased respiratory infections in young children.
Lead to lung infections such as bronchitis. A mistake during the final stage of the Apollo-Soyuz test project in 1975 enabled nitrogen dioxide fumes to enter the spacecraft, nearly killing the crew. Less well known are fatalities caused by NO2 on farms. Silo gas is formed by the natural fermentation of chopped silage shortly after it is placed in the silo. Nitrates in the crops get decomposed to nitrites, which react with organic acids, forming nitrous acid. This decomposes as the silage warms up to form nitrogen oxides, including NO2, and this has caused fatal pneumonia in unsuspecting agricultural workers.
NO2 emits when nitrogen is added to soil through synthetic fertilizers, produced from plants, soil, and water, released during the breakdown process of nitrogen in livestock manure.
There are several ways of making NO2 in the laboratory, the most dramatic being to drop a piece of copper foil into concentrated nitric acid, using a fume cupboard if you don't mind. Within seconds, the metal dissolves, forming a green-blue solution of copper nitrate and brown fumes. So, where does the NO2 in the atmosphere come from? Nitrogen is a very unreactive element, but during thunderstorms, the temperature close to a lightning strike is several thousand degrees, quite hot enough to make nitrogen and oxygen molecules react to form NO. As the air cools, this turns into NO2. That is a natural process, of course, but the same reaction occurs in internal combustion engines, where the temperature reaches around 2000 degrees C, as well as in power stations. NO2 is also generated by heaters and gas stoves in the
Home. A major source of NO2 is the burning of fossil fuels, coal, oil, gas. Gas heaters and coolers also contribute. Another source is environmental tobacco smoke.
When NO2 is produced in a thunderstorm, it can dissolve in the rain, forming a very dilute solution of nitric acid. This is a natural kind of nitrogen fixation, and when that nitric acid gets into the soil, it forms nitrate, which are absorbed by plants. NO2 formed by a car engine, especially on a hot summer's day, is another matter. Modern cars have catalytic converters, and one of their functions is to catalyze the conversion of NO2 back into nitrogen and oxygen. In the past, though, this NO2 escaped into the air. Even today, the air around some large cities with high levels of car ownership can take on a distinctly brown tinge. This is bad news, as NO2 is of course very toxic. Where there is a temperature inversion above a city, a layer of warm air can trap denser cool air underneath it. That results in pollutants staying at ground level and not dispersing, forming the photochemical smogs which afflict many cities even today. Sunlight converts unburnt hydrocarbons to more reactive molecules like aldehydes and ketones. These react further, generating peroxyacyl radicals, which react with NO2, forming peroxyacyl nitrates, PANs for short. Have you ever been walking through a busy city on a hot, sunny summer's day when your eyes start to water? No, it's not the price of the ice creams, it's NO2 at work again. PANs are responsible for your watering eyes and are also believed to cause skin cancer as well as damaging vegetation. In fact, peroxyacyl nitrates are naturally present in air, albeit in small amounts. This acts as a source of NO2, which is involved in the formation of ozone up in the troposphere. ONO, nitrogen dioxide, is no joke.
How to reduce exposure. Responsibility: maintain gas appliances. Buy a vented space heater instead of an unvented one. Use correct fuel for kerosene heaters. Kerosene A, thin oil distilled from petroleum or shale oil, used as a fuel for heating and cooking in lamps and as a denaturant for oil. Use an exhaust fan vented to outdoors instead of gas stoves. Open flues, a passage for duct for smoke in a chimney when using fireplaces. Choose appropriate wood stoves that are certified to meet EPA requirements. Make sure that doors are tightly secured. No section of the country has been found to be out of agreement with the current NO2 requirements. Levels of NO2 are highest on or near commonly used roadways, as well as large urban regions.